For lesson 5's homework, we're going to continue our work with our just more angles in our circle. So in the diagram below, YZ is the diameter, or is YZ the diameter, excuse me. Explain your response. Well, if YZ was the diameter, that would make this a right triangle with the square, with the right angle at X. So what we're going to do is we're going to check by plugging in all of our numbers here to Pythagorean theorem to see if they actually work. So 5 squared is 25, 12 squared is 144, and 13 squared is 169. When you add up 25 and 144, you get 169. 169. So that checks out that these two are equal. All right. So is that the diameter? Yes, because by Pythagorean theorem, this is a right triangle. Okay, so again, if that's going to be a diameter, angle X would have to be a 90-degree angle. So we did Pythagorean theorem to check to show that it actually was a 90-degree angle. And number 2, using the circle from question 1, determine the measure of angle XYZ and the measure of arc XY and round to the nearest tenth of a degree. So I'm going to bring up my dual display here so we can see it again. So if we want to find the measure of angle XYZ, all right, so we want to find this angle there, we'll call it theta, okay? So from there we have our opposite, our adjacent, and our hypotenuse, just like a trig problem. So now since they're all filled out, you can use whichever one you want. So since I haven't used tangent recently, that's the one I feel like using. So tan is opposite over adjacent, so 5 over 12. We will arc tan on both sides. Go to our calculator here, so second tan 5 divided by 12. That's what we get, and they want it rounded to the nearest tenth of a degree. So we're going to round it seems like they want us to round both of them. So then we'll be 22.6 degrees. And then if we multiply that by 2, because that angle's inscribed, we will get 50, sorry, not 50, excuse me. We'll get 45.2 degrees. Now what arc does that work for? That works for arc XZ. Well, that's not what they asked for. They asked for arc XY. Well, in that case, we know that that arc and arc XY add up to 180. So 180 minus 45.2 is going to give us 134.8 degrees. All right. So we found our angle at Y to be 22.6. We multiplied that by 2 to get arc XZ. That's not the one they wanted, but we knew we were working with the semicircle, so we subtracted it from 180, and we got 134.8. In circle F, points A, B, C, D, and E are located on the circle such that angle C is 119 degrees, and BE is perpendicular to AD. Determine the measure of arc AE. So they want this one right there. Okay. So in order to figure that out, we got to do a little bit of work here for this problem. Well, I know that angle A, so if I highlight my cyclic quadrilateral here, I've got there, 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 and there. All right. So I know that my opposite angles add to 180, so that will help me get angle A. So 180 minus the 119 is going to give me 61 degrees. Okay. So now I see I have a little triangle formed here, and I know that if this angle's right here, then that angle's got to be right. Okay, supplements. So then that's going to allow me to add those two together. 61 plus 90 gives me 151. And 180 minus 151 gives me 29 degrees. So now what I've done is I've completed my triangle here, and that 29-degree angle is inscribed to the X. So X is 29 times 2, which is 58 degrees. Okay, so again, we used our cyclic quadrilateral, opposite angles are supplementary. We used regular supplements here to get the right angle, triangle rules, and then inscribed. So now in number 4, we want to find the value of x. So all that gave us is that angle BDC is 57. Well, that looks like an inscribed angle, and if I point up here, all right, if I take 57 and I multiply it by 2, I get 114. So that tells me that this arc right here is 114 degrees. All right, obviously probably not drawn to scale. Now what we should notice is that x is inscribed to that same arc. All right, so x is inscribed to that same arc. So realistically, we didn't even have to do the 114. If you find that two angles are inscribed to the same arc, you know they have to be congruent. So then we know that x is a 57-degree angle. So in circle O, AC is the diameter. They gave you angle COD is 120, and it tells you that BD bisects angle ADO. All right, so we know that these two angles here are the same. So find the following and explain. All right, and I'm going to take out the explain piece here. You don't have to write anything down. All right, I'm just going to start filling things out and talk as we do. So the way I look here, angle AOD is supplementary. Okay, so 180 minus 120 gives you 60 degrees. Find the measure of angle OAD. Well, we know that this triangle is isosceles because it's got two radii. So therefore, we know angle OAD and angle ODA are exactly the same. Well, if that vertex angle there is 60, it's going to form an equilateral triangle. So that angle is also going to be 60. We want to find the measure of angle BDA. Well, if we know that whole angle is 60 and it's bisected in half, then we know we've got a 30-degree angle. Now it wants us to find the measure of angle BEC. Well, what we can do is if we have a 60 and we have a 30, what do we end up with here? Triangle, we end up with a 90. So then we use vertical angles to see that the other side of E is also going to be 90. Find the measure of angle ACD. Well, I'm going to erase this so we don't get confused that it's an arc. If they gave us the central angle here as 120, we know that arc CD is 120. We've got a diameter, so we know it's 180 degrees. So 180 minus 120 gives us 60. So since ACD is inscribed to that 60-degree arc, we end up with a 30-degree angle. And then our last one is the measure of angle ABD. Well, ABD is also inscribed to that 60-degree arc, so therefore it is also going to be 30 degrees. All right, so you can see how we carry over some of our old like supplement and triangle rules into some of these circle problems, depending on kind of how they play out.